Hello, you're welcome to Ekidel live stream, and I will say welcome. And my name is Engineer Justice Nwaka, and I'm your presenter for this structural design. As you can see that. Now, on our previous live stream, we performed this building modeling here, and the structural model of this building you are seeing here. We will have to model for the ground floor and the basement and all other floors, and then the swimming pool as you're seeing at the top here. And we didn't do anything about loading of the basement and loading of the of all the swimming pool walls and all that. We didn't do that. So we are going to on this live stream today, we are going to perform the structural loading of the swimming pool walls and also for the basement walls, okay? And for every other model that we didn't complete, for example, there are some parapet walls that is around the roof here. Since this is a roof building and all that, as you can see from the card file here, this roof here is meant to be used for like a bar, okay? As you can see that. So we are going to also provide for these parapet walls and all that. Now, before we continue, I would advise that I would like you to do what? To like this video and also give this video a thumbs up, and also you can also use the comment section, either the live chat and all that, to drop down your comments and all that. We are seeing you live now, right now. We are seeing you, Engineer Samuel, and also Engineer Masuba, and every other person. You're welcome to Ekidel live stream. Okay, and also you can also share this link to your group chats and also invite your friends and colleagues that they will also know what we are doing here on Ekidel, okay, and all that. Okay, so that's fine. So let's now move on back to the and complete what we are doing, okay, which is the structural modeling. So on this now, knowing what we are to do on this live stream today, I'm going to show you first how to load your basement wall and your swimming pool walls, okay? So right now, as you can see on this basement wall now, the first thing we'll do is to apply our load on all the basement wall, okay? As you can see that they are on section by sections, okay? That's fine. So on this now, I'll then click on the basement wall here, on one of the sections of the basement wall here. I'll then do right click on it, and then you will see, okay, now we are currently on the story 0, so you cannot do anything loading on story 0. So I'll come to story 1 where it is, because story 0 is for the foundation. So story 1 is where we'll have the basement wall, okay? So click on the basement wall again right now, then right click now, and then you have to do click on the place that says you see here that says edit load, okay? So I'll click on the place that says edit loads, okay? That's fine. So why we wait for it to do to appear, okay? Once it's appear right now, okay, so on this place now, you can see that we have several load types here, okay, to load your basement wall, okay? But right now I would need to explain this for you now, okay? That's fine. So most of the times, most people used to apply wrong loading when it comes to basement wall, okay, which is very bad, and it's not right to do that. So now basement wall basically has doesn't really have wall surface load area. What it has is soil load, okay, except you are designing for oil and gas sector. That's kind of structure. That's where you have to do apply soil load and also point load, because most times the pipe that is carrying the oil, that is carrying those fluid, can tends to penetrate into the wall, like let me say penetrate through the wall and then continue is flowing, okay? So with that now, that pipe that passed through that concrete wall is now acting as a point load directly within the point where the pipe passed through. So with that now, that's a point load. So you also have to consider point load at the coordinates, at the point where that pipe will pass through. So you need to apply the force of that crude also on that plate. But right now we are not dealing with oil and gas design. We are dealing with normal infrastructure design, which is building design, okay, and all that. So with this now, there is not like pipe punching through the walls and all that. So we are going to apply directly soil load on the face of this basement, okay? So that takes us now to this place that says soil load here, okay? So on this soil load now, we will just allow it to do to display, okay? okay, because it will display a different dialog box. That's because we clicked on what, on the soil load. Okay, so let's allow it now to do what, to display. Now when it comes to loading, you must be very careful when you are loading what, loading your structure, okay, because if you do a different loading that is wrong, then you have issues on that. Okay, that's fine. Okay, so right now I can see that I will then come here and then click on this place here that says what, on this surface here. Okay, now on clicking on this right now, it will display a dialog box that we are going to what, use. Okay, I just hold on for that to display. Okay, that's fine. So you can see that it has now displayed this load here, but before then I would like to close here first and then do what, delete every load that we have. Okay, no load here, then make sure that there is no load yet, then come back now and then click on this soil load here and then click on this surface here. Now on this now, then most people tends to do what, tends to just apply their values and all that, not knowing that they are meant to do what, they are meant to make some settings. I see some videos on YouTube, they just come here and apply their load wrongly, very wrong. Okay, very wrong. Okay, that's fine. So right now I'll be showing you the right way on how to apply your load on your basement wall or on your retaining wall based on the type of soil that is found on the region or on the area where the structure is meant to be built. Okay, that's fine. Okay, so with this now, let's now go with what we have now on this. Now I can see that this place now says what, model type, sorry, model label. This place can be type anything, you can just put in any value here, but me, I choose to leave it as what, default. Okay, then on this place now that says what, load side. Okay, it's basically what, on active and not passive. Okay, because it is the wall that is what, trying to retain the soil. Okay, so the soil is trying to push the wall away and not the wall trying to push the soil away. So with that now, it is an active what, pressure. Okay, then this place that says what, long-term load and short-term load. I'll just use one word to explain this. Long-term load is simply let me say, trying to design for worst condition, while short-term load is what, if you are sure that that basement wall, let me assume that during the construction, knowing that after they have finished constructing the basement and they have done what, backfill, if that's like, let me say, 30-story building, you can see that there will still be other vehicular activities around the basement, for example heavy duty vehicles passing through. So with that now, they are causing load on the soil, and since the soil is being loaded on the surface, it will do what, try to push some soils, and when on trying to do what, perform that soil what, when that soil is trying to do what, move, it will now find what, it will now come and find this wall here, this wall, which is now serving as a retaining wall to now resist the soil from pushing into the structure. Okay, or let me say into the basement. So with that now if you are sure that vehicles that are passing through that place is just for a short time, or the load that will act on the surface of the soil around the basement is only just for a short time, then you can come here and choose short time. Okay, come here and choose short time. But in my own advice, I would advise to leave it as what, long-term load, because you don't know what will happen later around that area. Okay, and that, so leave it as long-term load, knowing that we design for worst condition. Okay, generally if you're doing your design of structure, you design for what, for worst condition. Okay, that's fine. So with that now, leave it as this place here that says what, long-term load. Okay, and all that, you can leave every other thing here as default and all that. But if you have your water table level, you can do what, input the value here. But if you don't have it, then leave it as default. Now then move to what, settings here. Okay, I will still walk you through back to the model, because we need to go and get the height of this wall. Okay, but currently the height of the wall have just come here what, automatically to this place at what, 2950, knowing that our height of what, of the story one where this basement is what, 2950. To now show you that, let's now go back to the CAD file now. To the CAD file here, you can see that we have let me just go there right now and then shift this a bit and maximize this. Okay, that's fine. You can see that from our basement here, can see that our basement here, if I measure now, this is the basement area, okay? From the top of the slab here down to the top of this slab here, we have what, 2950. So this is how we got our what, height of wall, 2950, okay? Then minimize back now, and on this place you can see that we have a custom value here, 2950. That's because we have already set all our story heights when we did what, during the modeling of the stories, okay? That's fine. So with this now, we're now going to do what, move into the settings, okay? Now on the settings here, know that we are using what, European code, okay? So you have to choose your own code on the code you're using, but for we right now, we use what, Euro code, okay? And all that, because that is the most recent code and all that, okay? So that now, we now move to what, spectral type. Just leave it as what, 2, okay? Type 2. And on this ground type, I'll just leave this ground type, because you only pick this ground type if you are working on, or if you are doing a design for the area that have what, seismic or earthquake, okay? Earthquake, that's where you have to choose this ground type. And once you choose this ground type right now, you will see your values here showing here, okay? But you can choose to do what, edit them, okay? For example, now I don't want to choose any ground type, because once I choose any ground type right now, that means that I have applied the ground type to this structure, and this is not a seismic structure. We are not designing for a seismic load or design, okay? So I'm not going to choose that, okay? Don't choose that. Then now move to what, soil profile, okay? Now on this soil profile now, you can see that we'll have two soil materials here, which is what, the sand and what, the rock, okay? Now I see most people just putting their values just like that. Now know that if you don't have rock in that area, or where this building is to be sited, there is no need for you putting a soil material as what, rock. You can choose to remove. That's why you have what, remove and what, add. And if you have any kind of soil again, like silty clay or clay, you can choose to come here and add that soil, okay? You can choose that. If I go now, you can see that there is a different soil here. Can you see that we now have what, number of soil. You can now choose to come and do what, add your soil here. Click here and choose the type of soil, because just hold on, it will show the type of the soil layers right now, okay? Just hold on for that. So you will have to do what, choose the type of soils. And if you have only one type of soil, which is sand, then there's no need for you leaving all other soils there. It will affect the design of that retaining wall or basement. So you can see that we have clay here, silt and rocks, okay? So if I want, if maybe I have clay, based on the soil report, there is clay, I'll have to come here and add clay to as a list of what, soil materials here. So you can see that right now that we now have what, sand, clay and rock. So if maybe I don't have rock, I'll have to do what, come here and remove the rock, okay? So for example now, in this building we have only sand, so because of that there is no need for me having rock and sand as my soil layer on this basement. So I'll have to come what, remove all other soil layers and leave only the soil which I what, have, okay? So with this now, I'll then come here, click here and then do what, remove, okay? I have to remove that rock, you can see that. Then come again here, click on this place now and then remove also here. So with this now, I have only sand as my layer, okay? As my layer, or sorry, as my soil what, material, okay? That's fine. Then now I'm gonna come here right now, then do what, click here and then type in my what, the height of the sand, which is basically the height of the basement, okay? But if you feel that the sand will not cover the basement evenly, then you can then do what, put the height of the sand, okay? For example, we have partial basement, okay? Basement that part of it is what, inside the ground, and part of it is what, above the ground. So with that now, that's a partial basement. But if you have a fully submerged basement, then you have to put the total height of the basement here and then press what, enter, okay? You can now see that this is what, a fully submerged what, basement. As you can see from our CAD file here, also from our picture here, you can see that basically we have a fully submerged what, basement, as you can see that right now, because this is the ground floor and there is no basement wall showing here, because if it's a fully submerged basement, sorry, if it's a partial basement, we are going to have what, we are going to have an opening around the bottom here, okay, either for windows or just to bring what, vent, okay, and all that, okay? And if also check for the other image too that we have here, you can also see that there is no trace of what, basement showing here. Now to now show you fully, right, let's now move on to the CAD file, okay? Now on the CAD file here, okay. You can also see that, let me just make it bigger. You can also see that this is the ground floor level, okay, and you can see that it is fully, basically it's fully what submerged into the soil, okay. So that's why you can see that right now. So I want to use what okay, you can see that, okay, sorry, you can see that we have what let me just see that from here to here we have 1 meter, okay, 1 meter above, okay, and 1 point something meters below. Let me just, from here to here right now is what 1.8 meter, okay. So we have the soil, okay, 1.8 meters, and this is now above the ground level, okay. So you can see that it is not fully submerged, okay. It is what partially submerged. So 1.8 of the basement is inside the soil, and 1 meter is above the what ground level, okay. That's fine. So let's now go and do what, modify that, okay. Then minimize this right now, and then come here and put the height of the level inside the that is submerged inside the soil, which is 1800, okay. That's, and then press what, enter, okay. So this is how we have got our basement, okay, and all that. Now we will now move on to the next one here, which is what such charge here. Leave everything here, don't put angle, okay. Leave everything here as default, except you are sure that the soil is at an angle, but I would advise to leave it at what, 0 degree, okay. That's fine. So now we then go over to what, such charge here. So on this such charge right now, you can see that we have different, we have 2 loads here, which is what, point load and surface load. Remember from the beginning of this basement, I explained about what, about the point load, where if you're designing for, let me say, an oil and gas structure, where pipes can also penetrate, the pipes carrying the crude oil or the fluid can penetrate into the walls and then continue its laying, okay. Now with that, now you have to apply point load at that particular place. Let me assume that there's a pipe passing through this through this wall here. Let me say a pipe here is passing through this wall, so you have to apply what, the point load directly on this area. So you have to apply what, the magnitude on this A and G and all that, and also the distance where they apply. But right now we don't have point load, so we have to do what, remove the come here and remove point load, okay. So we have only what, surface load. That's the load that is going to occur around the soil, around the surrounding perimeter of the basement, okay. So now on the load, now we have only what, surface load. If you check now, you can have that we have different load here. Basically the load that that applies on a basement wall is what, point load, all right, surface load, all right, and then strip load, and the final one here that says what, line load. So these are the possible 4 loads you are going to have on your basement wall loading, or even if it's not basement, as long as it is retaining a soil. These are the possible loads you are going to do what, encounter, either point load, line load, strip load, and surface load. And this this load type now have their functions, okay. There are places where you're meant to use them, okay. For example, we don't have point load on this because on this building, because there is no pipe passing through the reinforced concrete wall or the basement wall. So right now we have only what, surface load, which is the load that is occurring only on the surface of the soil, which is the sand right now around the perimeter of the basement, okay. That's fine. So right now, when it comes to basement wall loading, as you can see, I've already told you about the types of the type of load you are meant to encounter, which is the source charge and all that, the point load, line load, strip load, and surface load. And we are dealing right now with what, surface load, okay. Now once you have picked your surface load, that the next thing now is to do what, is to put in your magnitude, all right. This magnitude simply means the load of that surface load. For let me say, for example, if it is a vehicle that will be passing through the perimeter, for example, if your building is close to the road, all right, and knowing that the most occurrence load that can pass through the perimeter of the soil is human load, and either circular human load, bicycle load, motorcycle, and vehicle. So in that, now you can now know that the among all this type of load, the maximum load that can pass through the soil around the perimeter of that basement wall or retaining wall is what? Vehicle, because that's the maximum load among all the loads which I have just called now: human load, bicycle load, someone driving a bike, motorcycle, and then the vehicle. Okay, now knowing that now, and we design for what? Worst condition. Okay, so with that now, we are going to deal with what? The vehicular load. Okay, now when it comes to vehicular load is divided into two parts. All right, into two parts, and that is what? HA load and what? The HB load. Okay, the HA load are like the minor vehicles, for example saloon cars and all that. Why for the HB load are for the heavy duty vehicles, for example trucks, caterpillars and all that. Those are for what? HB load. And knowing that we design for the worst condition, it is good to use HB load when you're designing for your what? For your when you're picking for the vehicular load. Although if you're doing for when you're designing for what? Bridges, we use the two loads, HA load and what? HB load, for the design of bridges and all that. Okay, and even at that, you will see that the HB load, which is for heavy duty vehicle, is what they will consider more to use. Okay, now when it comes to such charge load, in terms of basement wall or retaining wall, as long as the wall is what? Is trying to retain a structure, then you will have to use the HB load. And from BS code and Euro code, the minimum such charge load that you are to use is what? 10 kilonewton per meter what? Square. That's the minimum. You can see that at a default we have what? 30 here. Now I'll tell you how this 30 came to play. Now this 30 comes to play here is because this software, knowing that all softwares, basically Protastructure and other design softwares, are to do what? They are designed to do what? To fight against what? Structural failure. So even if like let me say instead of that building to fail, let it be that that you perform what? Over design. So they tend to do what? Over impute the values. Okay, so this 30 here is too much. Okay, as for magnitude of what? Surface load, because when it according to Euro code and BS code, Euro code and BS code says that, okay, now we are using Euro code, but know that it is the same what principle. Euro code says that now for HA load and HB load, the maximum surface load is what? 10 kilonewton per meter square to 20 kilonewton per meter square. That, so you can pick any load from there depending on the activities you know that what occur around the perimeters of your basement or your retaining wall or structure. Okay, so with this now, knowing that 10 is the minimum and 20 is the maximum, although you can choose to exceed if you know that much activity will like occur there. For example, if crane will be passing there, which is not that common to be passing, then you can then do what? Increase your load. Okay, so for surface for such charge load now, knowing that 10 is the minimum and 20 is the maximum, then I would say you always stick to what? Maximum for the what? HB load. Okay, which is the what? Vehicular load. Okay, HB load, which is 20. So with that now, we'll put here 20. Now the reason why this software tends to choose what? 30 is because, for example, now that they have known that the maximum is 20, all right, so they assume that since the code has said that the maximum HB load is what? 20, all right, just to design more safer, they want to do what? They want to increase the load by what? Adding 10 additional, knowing that there is no vehicle, there is no load that can reach up to this 30. So this is the highest they can do that. So but for me, I will not want to do this. I want to stick with what the code says, which is 20, because even the code, people that wrote the code have already done their own experiment and also research, and I've seen that 20, which they said is the maximum, can go for any kind of load. Okay, so right now I'll come here and put what? 20 here. Okay, 20 here. Okay, that's fine. So with this now, once I have done this now, that means that the such charge load on this sand which is being retained by this soil is what? 20. The load running there is 20. Leave all these places as what? 0. Don't put distance, because if you put distance right now, that means that the load is only running, let me say, from the wall to this area here. Now what if the load runs here, or let me say the load only falling from here to this place here? Now what if the load runs here? So leave it as what? At let it run what? Entirely. Okay, don't put anything distance here. Okay, that's fine. So with this now, I'm going to come here and then do what? And click on what? OK here. Okay. Now you can see that we now have our our soil load now on this place here. This is for the self weight. Okay, self weight load. So leave this as it is. So right now, once you have done this loading right now, then come here and then do what? Click on what? OK. Okay. Now on clicking on OK, just now we have now loaded this soil. Okay, if you hover your mouse now on we have loaded what? This basement wall section here. If you put your mouse here now, you can see that we have a load there showing there. Can you see that? So you got so next to do right now is to do what? Right click here. Okay, and then copy what? Copy load. They will ask you to what? Copy the what? Soil load. Okay, say what? Yes, copy. Okay, copy it now. Now on copying it now, we will then move on to what? Move to clicking on the next wall and hold your control key to do what? Pick all the walls except this one you have already done. Don't pick it twice, else it will add the load as twice. Okay, so you just do what? Then rotate now and pick all the walls that we have here. Okay, pick all the walls here by holding your control key and pick all the walls there. Okay, all the basement walls, and then once it's done picking that side, I'll not turn the other side again. Then I'll not turn again now. Turn here again. Zoom in here. Click this and click this and click this. That's fine. Okay. And then rotate. Now most times when you do an auto highlight like this, it might not paste the load in all of them. So let us try first and see by do what? Paste here, and then hold on for that. It will display something for us to say okay. Just hold on. Okay, that's fine. So right now I can see that. Let's now check now if the walls has load. So we stopped on this side, so we have not done anything on this side here. Okay, let's now confirm if the walls have their loads. Come here. Let's start with this one here. Let's see. Hover your mouse on it. Yeah, you can see that we have soil load. Now if I choose to open here now, let me just do that right now and edit load. Let me see that. Let's see. You can see that we have soil load here. Can you see that? Yes. So it's not showing. If I also come now and then come here and click on any of this one here, right click now and edit load, you see that we have soil load there showing there. Let me see. Can you see that? Okay. Now if I now rotate now to this other side here, which we have not loaded, if I click here now, right click here, you see that there is no anything like soil load there. Edit load. You can see that there's no soil load here. Okay, that's because we have not yet pasted anything about soil load on that line. So now come again now and continue from where I stop here, this other one here, and then hold our control key to make sure we paste the load on every all the wall section here. So this is the right way to model your basement and also to load your basement. Maybe later I can do a video on just basement wall loading and then explain more if maybe you don't get that. So right now then come here, right click now, and then come here and do what? Paste here, paste, and they'll ask me to paste only the soil. I say yes, only the soil load. Okay, it's there. So if I now come and check any of this now, let me just check any of that. Let's just check here right now. Check here, right click here, and then come down and say what? Edit load. You see that we have soil load now on that place. Okay, you can see that right now. And even if we check this other one that we did here before, that was not having any soil load, right click now, you see that there is a soil load now because we have done what? Pasted that. Okay, let me just do that right now. You can see that we now have what? Soil load, right? That's fine. Okay, so with this now we have now modded apply load on what? On all our basement walls. Okay, let's now go and also apply load now on this our swimming pool wall and on this our swimming pool slab, because there is no load here. So let us navigate to what? Story 5. Okay, which is the last floor where the pool is. Okay, now on this story, once it's active now on this story 5 now, let's now look at this slab here. This slab here for this basement, okay, for this swimming pool. Right click now and then say property. You see that there is no load yet. What we did last time was just to put in the levels and the depth. You can see that there is no load on it, so we now have to do what? Apply load now on this. Okay, now how do you apply swimming pool load, or how do you get your load of your water around the swimming pool walls and the slab? Okay, now let's not take us back now to the CAD file. Okay, now back to our view here. This is what we're about to do. Let me just show you that right now. Come here, just come here right now. What's done? Okay, we are about to now impute the load of this water, all right, of this water here around the pool walls, okay, and also at the pool slab. Okay, now you can see that this water right now is directly at the top, although there's an opening which you will see on the CAD file where the water stops. So from the CAD file here now, like I said again, if you need this CAD file, you can just purchase it from the link down below and then begin your own design for that. So you can see that from the CAD file here, okay, from the pool side here, so that there's an opening which is what? Orifice, okay, an orifice, so that this pool will not have what? Overflow, okay, because it's not really no, there is different kind of pool. They have what? They have what they call what? Infinity pool, okay, but this is not an infinity pool that will have to feed to the brine and start pouring out. Okay, this is not an what? Infinity pool. This is just a normal regular pool that has an opening to do what? Control the what? Any kind of what? Water what? Overflow. Okay, that's fine. So with this now, we have to measure the height of this place. So we measure right now from here, all right, I can take from the top of this opening here. Let me just take from here to this place here. What do we have? Because the actual height of our water is what? 1660 at this, sorry, 1360 at this place. Then at this place here, the actual height of our water at this place is what? Let me just say that right now. Is what? From here to here is let's just say 1620. Okay, then from here right now, the actual height of our water from here, which is the deeper side here, is what? Is 19, let's say 1920, or yeah, 1920 or 1915. Okay, that's fine. So with this now, let's now go and begin to do what? Load it based on the how the water volume is on each of the depth. Okay, now let's start with this beginning side here, which is more shallow, which is what? 1360 is the height of the water on this side, which is basically on this side here, on this side, yeah, because this is the one that is more shallow here. So now click on the slab here, on this slab here. All right, let me just do that now. On this slab here, let me just do that. Let me just take that. Okay, that's fine. Then right click here and do what? Click on what? Edit load here. Sorry, properties here. Properties load. That's fine. Then come now. All right. Come now on the load here. Now, how do you get your load? Knowing that we have gotten our what height. Okay, we get our load by using what? By just doing small side calculation like this, something like this. Now we know that our height is what? 1360. All right. Now we have to convert this what? Convert this to what? Meters. Okay, so divided by what? 1000, we have what? This, which is 1.36. okay, now the fastest way to like get your weight of your water in a pool is to do what? The height multiplied by what? By the density of water. Okay, so the height multiplied by the density of water will give you what? The weight of that water. Okay, so right now the height is what? 1.36 multiplied by what? 10 is the what? Density of water. Most people take 9.81 and not that, but I think most people also take what? As of 2004, sorry, no, 2000 I think 8 yeah, 8 thereabout, the density of water was changed from 9.81 to 10.0. okay, so right now we are going to use what? 10.0. so now come here and do what? Click on this right now. Come here and click on what? Okay. So with this now, the density of the weight of the water on this on this area is what? 13.3. okay, so we'll go now right click, sorry, not right click again, come here right now and then put in the load here, which is the what, imposed load, because the water is what, imposed, okay, because most times this pool might not have water, so because of that, the water becomes what, a live load to this swimming pool here, okay. So we'll put what, 13 point, let me check what we have, 13 point something 0.6, okay. So right now go and put what, 13.6.6, that's 0.6, that's fine. Now the dead load now, the dead load that can happen to this pool is that even when it's dried, all right, when there is no water in it, human load can enter into it to maybe say go and do some cleaning or services, you understand. So with that now, we'll now apply what, the human load in this pool, all right, which can be which is going to be 1.5, okay. So I apply 1.5 as a dead load, okay, then 13.6 as a what, imposed load, which is the live load, which is water, which is the what, weight of the water around this area here only. Then now come and do what, click here and do what, update here, okay, and then come here and do what, close, okay. So if we now go and check out this now, just again open, you see that it now has what, a load here. Can you see that? A load now is now added that. So also here again right now, this other side now, which is this there is center here, also go and check out for what, for the load here, and then you can see that it is what, empty, no loading. Back to our CAD file now, let's go and confirm the height of that place. I think one something 1.5, I don't know, let's see that. This is that side now is what, okay, 1.621. We can okay, 1.621, okay, that's fine. So let's now go do that, 1.621. So 1.621, that's the height of the water, okay. So with this now, 1.621 multiplied by what, the density of water, which is 10, that is what, 16.21, okay. So come now, put here 16.21, and then the human load, which is the dead load when there's no water in it, 1.5, okay. Then come here and do what, update, that's fine. Then close, come again here, which is now the what, deeper side here, okay. Just like this, okay, right click here, properties, okay, and then come now and then loading here is still what, empty, 00. Then come now and confirm the height of that place to your CAD file, okay, CAD file. This now gives us what, you can see that we have what, 1913, okay, 1913 is the actual height, okay, of the water. So come back now, calculator, QC, or just open that place, 1.913, okay, multiplied by what, 10, that gives us what, the weight of the water, which is what, 19.13. So come now, edit this live in water load, 19.13, okay. Then come here and put in this place now 1.5, okay, and then come here and do what, update here, okay. So with this now, knowing the values that we have here, we also apply the load also on the walls here, okay, on the walls here. Let's start with this wall now, this wall here on this section, okay, which is what, 19.13. So come now, click on this, all right, click on that wall, okay, on this wall now, right click here and do what, edit load here, edit load. Now knowing that when I was showing you about the basement wall loading, okay, we dealt with what, we dealt with soil load, but right now there is no soil load on this swimming pool, right, because it is what, elevated at the roof, so there's no soil. Now what load will you now use, okay, that tells us what, wall surface, wall area load. So we are going to use what, wall area load for that, okay, to apply what, our value for our pool, okay. Now on the wall area load now, the next thing we do right now is to do what, put in our what, magnitude of what, of the load, knowing that it is what, imposed load, okay. So I'll come here and choose what, Q load, okay. So on this Q load now, I'll then come here and then do what, input my value here, magnitude 1, okay, 19.13, okay, again 19.13, okay, and then I'll do it to what, inside by what, distance, okay, and the distance now I'll do what, click on this place here and say insert at what, 00 offset, and then come here, okay, and then click at the wall here, okay, then wait for it. Now you can now see that we don't have our surface load here. Now come here and do what? Click on the what updates here. Okay, that's fine. So we now have our what surface load here. If you can see that this is now our what water load at the face of the wall. The first one there is the dead load, and here is what? Okay, you can see that right now. You can see the load here, the water load now. Then come and do what? Say okay here. Okay, that's fine. So with this now we have applied what load on this wall. Okay, now I have to copy this wall load now. Copy now, copy load. All right, they will ask you this Q, that one, say okay it, and then paste it on all these other walls, not on on all the walls, on the one on this section that is deeper only. Hold the control key, right click anywhere, and then do what? Paste. They will ask you again which other one. You say yes, just paste it to paste. That's fine. So right now on this other one now, let's now confirm the load here. Let us check on the slab here that we have here. We have here to be what? I think 16.21. I don't know. Sorry, I thought we apply load on that slab. Let me check again. Let me check one here. Confirm here again. Let me see if there is load here. Confirm this other one here. Yeah, this is okay. That means this one we didn't apply load on this second. Let me see this last one if there is load on this slab here. Confirm this other one here. Properties. Let's see. So make sure you are loading your, yeah, this 19. So that means there is no load on this other second section, okay, of the pool. This is what? Let me see. No load. Okay, so let now confirm the this again, the height again. Okay, the height now. The height here is what? Is 16.21. okay, that means that times 10 will give us what? 16. Yeah, 16.21 will like be the load of the water, just a times 10. So right now 16.21 and then 1.5, okay, and update it. That's fine. And then say what here? Close. Okay, that's fine. So with this now, we then click on this wall now and then apply the same load here. Right click here and edit load here. Okay, then come down and then choose what? Choose surface wall area load here, and then come and change to what? Q load. Okay, that's the water load. Then come here and put what? 16.21 and then 16.21. okay, and then come here, insert by what? Distance, and insert towards 0 distance, and then do what? Click on it to insert that load, then update. That's fine. So you can see that we now have what? Apply load on this other one here. That's what? 16.21. Can you see that? 16.21. okay, so with this now, then go here and then do what? Okay it here. Okay, now on now okaying this now, then do what? Copy this load now. Copy this load, yes, copy into this other side here of the pool here. Click on this one here that is on the same section of it, then come here and paste. Okay, that's fine, that's okay. So with this now, if you hover your mouse now on this, you can see that we have what? The load of what? Area load is what? 16.21, and here is what? 19.13. okay, so let's now go and load this other section of the pool here, this other side here, 1, 2 and 3. okay, this other one here. So come now, click now on this. We have already known that the load on this slab is what? 13.13. I don't know, let me just see that. 13.13. let me see. The load here is what? 13.6. that's fine. So come now, click here, right click here, okay, on the wall, edit load, then click on wall area load, right, then change to what? Q load. okay, then come now, put in the value 13.6. okay, and then 13.6. okay, choose by distance, insertion 0, and then make sure you click here. okay, and then click on what? Update. You can see our load here 13.6. okay, that's fine. So with this now go what? Say okay here, and then copy the load now. Once it's done, right click on it right now, and then copy the load here and say okay. So we will then copy it now and then click on this other one here, and then click on this other one too, and then right click here and then do what? Paste now. okay, that's fine. I'm tired, man. So right now we now have what? All our load here. You can see right now we have what? The area load, what? 13.6 and all that. So we have now applied what? Load on this swimming pool wall and all that. okay, so the next thing now is now begin to do what? It's now begin to run our building what? Analysis. But before then, there is still some things to model at the roof, which is the parapet wall here. Let me just show you that, guys. Now the parapet wall here, all these walls here on this place here. Okay, we need to model these walls here, and also you can see that the wall height here, all right, is different from the wall height here. So we want to model all that too. Okay, so that takes us now to go and do the modeling. Also, the wall height at the back here is more higher than the wall height here at the front here. Okay, that's fine. So with this now, let's now look at the CAD file. Now begin to do model the wall load on this area. Okay, that takes us now to the so this, but before then, let's go do let's go and do okay, let's do that wall load first before we now go and do the next thing, which I'll show you. So back to our CAD file now, CAD file here. Okay, so you can see how CAD file is very important for when you're doing your design. Okay, you must have to refer to it. Okay, so right now you can see that clicking on this right now, you can see that we have load of the wall of 1.5. okay, and also you can see that we have wall of 1.52. Can you see that? Basically we have wall of 1.5, as you can see that, directly around the perimeter of that area. So we're going to do which is the parapet wall that is wedging, that is just covering the people that is sitting around the roof. Okay, so right now we're going to do that right now by doing clicking on any of the wall here. Just click on this right now, and then right click here and do edit loads. That's fine. Now on this now, I'll then come and do wall load. Okay, wall load. Then come here, the same wall unit with 3.47 is okay. Then 1500 as a height, which I've measured already. 225 distance, and then come here, click on this, then come here and make it to be 0 and 0 and insert, and then come here and do update. Okay, and then come here and do okay it. That's fine. So you will now be able to see that we will now have our parapet load now is not showing here. So I'll just quickly right now copy this load. Now I click now and then copy. So we'll then copy right now to all other perimeter walls around the roof to input our parapet. I'll just hold my control key to make sure I do a multi-selection. Okay, multi-select right now, click here also, and click this other one here. Okay, and again rotate now. So you can see how we have just done this. You can see how we spent over 30 minutes loading our basement wall and also our swimming pool. Okay, so I'll then continue again to now paste my parapet wall. Okay, hold my control key down. I'll skip this staircase area because here is going up, so I'll continue from here. Okay, and then continue from here again, and again from here, and then here. Okay, and then rotate now. Okay, and then come here and do this other one here. Okay, and also here. That's fine. And then come again now, rotate here. Okay, and then come here. The wall is going like this and go the way down here. All these ones here are smaller, are 800. Okay, so I'll come again now, rotate here. Okay, hold my control key again, click here, and then click on the next wall here. Okay, and then go again now and click on the final one here, and this other one here too should be clicked, and then this one here should be clicked. Okay, and then we also go down like this, have it also around the pool here. Click this, and then click this other one here. Okay, and again come this side, click this here. Okay, and click this other one here. Okay, and then click here too. That's fine, that's okay. And again I'll also come here and then click this other one here. Okay, that's fine. And again come here also, and then click this other one here too. Okay, and again come here, just rotate it now to see the other part. Okay, and then palm a bit forward, and then come again and click on this, and then click on this here, and then click on this here also, and we are almost done loading this. And then this other one here. Okay, and then we have it around this place here. We have something here. Yeah, that's fine. So then we now right click now once you're done selecting, and then do paste copied load. Just paste the load, paste load, and you see our parapet load now will not appear on everywhere. That's fine. Okay, then click on escape key. That's okay. And then you now come, if now check that we have parapet load now, as you can see that. Now let's now go and look at this, yeah, now we now have a different load here. So click on this right now, right click here, the height here is what, 800. So come here and edit loads. Okay, that's fine. And then come here just now and then change it to sorry, wall load again. Then come now and change it to be what, 800 height of wall. And then insertion, I'll put here 0 and then what, 0, and then click first, and then sorry for that, then come here and do what, update, then come here and do what, okay, that's fine. So with this now, we then go over now and then copy this. Now we now have our load here. We then copy this right now, copy the load here. Okay, copy this and then rotate now and paste the load here. Okay, and hold my control key to select all the other ones here. Okay, here too, click here and again rotate again, click this other beam here and then click this other one here and rotate again. That's fine. Rotate now and click here again, turn again, and then click here and here and the final one here now, here. Okay, that's fine. So with this now, you can now see what we have done so far. We then come now, palm it now. Okay, palm a bit, and then right click now and do what, paste. All right, and then hold on for it to paste. Okay, that's fine. Then escape and then click on anywhere empty space here. Okay, that's fine. So with this now, you can now see that what we have just got now. You can see what they've gotten now. Okay, let's now confirm from the CAD file if this is what we have. Okay, now from the CAD file now, I believe we are wrong with the modeling on this pool area. There is no wall there. Let's just confirm that first. From the CAD file now, you can see that. Let me just see. Yes, there is no wall on this area here. So we got that wrong. Okay, we are going to remove that. Okay, so come back to this place now, and then on the let's just go back to plan view. Let's do it on plan view and be able to select the beams faster. Okay, plan view now. So on the plan view now, we then come now and then I hope you are still inviting your friends. Come to story 5. Okay, or story 5. Make story 5 active. Okay, it's entitled to load. So then click on these beams now and remove the wall load there by holding our control key to make a what, multi-selection. Okay, and then I'll click on this now. Okay, and again come here and click on this and click on this one here and then click on this here and also on this here. That's fine. And then come here, click on this and also on this here. That's fine. And then come now and click on this here. Okay, and then yes, that's all for that area. Then right click now and do what, delete load. Yes, say yes, delete load. Wall load should go off. Okay, now if you look at the 3D model of that face, we have a wall, we have a array load that is guiding these people here. So then go over here now, back to our this thing here, video this thing here. You can see that what we have now, we have array. Can you see that? We have to get a model for this way. We also have to add a load for this way. Okay, so if you zoom in, you can see that we have a array here. Can you see that array is at this place here, by and covering the pool. Okay, so we then go now and do that modeling. Okay, so come now, click on this here. Okay, and that array is found around this place here. So come now and then we have to do what, use our what, use the loading here, loading here, apply line load. Okay, line load here. Okay, and then put the is a dead load. Okay, so come here and put dead load here, G load, and then the load here is 2.5 because that's for the weights. And then come now, click on this place here, and then I can choose to go all the way down here. Since it's a way, I can choose to go all the way down here and click here, or I do it towards beam to beam and all that. Okay, do this like this just now. Let me just hold on for that to insert and all that. Okay, so with this now you can see that we are almost done. Let's just hold on for that to insert. Basically I would have done it beam to beam and all that, but let's just hold on for that to insert. Okay, Okay, so I think it's not trying to insert, so let's go and insert it beam to beam. Okay, so come now, click here, all right, and then click here, and then wait for it to insert. Let's see that. Okay, yeah, it's there. So right now do beam to beam. Okay, so come now again, insert here. Okay, and again just wait for that to insert. Come again now from here all the way down to this place here and insert. Okay, now again I'll then come again now from here, click here all the way down here and insert. Okay, you can see that there is a wrong hinge in here, so I'll have to remove this hinge here later. And again come here from here all the way down here, okay, and insert. Okay, so let me now show you now on the 3D view what we have just done so far. This is what we have done. Let me just show you right now what they've done so far. Okay, so let me just show you that yeah, this is what we have done so far. Can you see that? So this is basically what we have just done right now. We have done this. Can you see that right now? We have applied what? The load there on that way. As you can see, also the way here, which is here. Just hold on for that. It's coming up. Okay, here, yeah, this way here. We have done for this this way at this string here. Okay, at this face here. Okay, so let's now repeat it for the other ones here. Okay, that's fine. So with this now, I then come here and just minimize. Okay, then back to our plan view here. Okay, so with this now, let's now go and do what? Apply the load also on that area. So I'll come now again, loading here. Okay, then click on what? Line load here. Then sorry there. Then 2.5. Okay, and then apply my load now from here all the way down here. Okay, hold on for that to insert. And again from here now all the way down here. We still have a wrong hinge in here, so I'll have to make that later to correct that. Again from here to here. Okay, that's fine. And again from here, okay, to this place here. Okay, that's fine. And again from here to here, that's fine. Okay, sorry, from here to here. Okay, and again from here all the way down here, that's fine. So with this now, we now have our ray rounding all the pool, which is the load, basically the load that we have applied, okay, for that ray on the beams. Okay, that's fine. So we now have this now. Then we now move on to the next part now to now go and verify that hinging issue, else it will have issue on the beading analysis, because we are about entering into the beading analysis now. So come now and click on this, and also click on this other side too, click on this here too. Okay, then right click here and then say what? No hinge, apply. Okay, then here right now, this is that beams here are meant to be hinged to the pool. So come to the pool walls. So come now and click on this. Okay, and then come here, click on this here. Okay, hold my control key, and this is that one too, and the final one here. Okay, that's fine. So then come now, right click now and do what? Apply hinge at what? Oh sorry, we are meant to hinge only these parts. Sorry, so let me just pick J. Okay, J first. That means I have to change here later. I thought they are, sorry for that. So here now, this one now be what? Is here meant to be at what? At the pool. This hinge here at the pool end. As you can see that this one is at the pool end here. So let us now go and change this to what? I end. Okay, here becomes what? I end. So come now, click on this again. Okay, that's fine. And then right click now to change to what? Hinge at what? I end, and then say what? Apply. That's fine. So now we now have our hinge what move to what? This, which is making this beam not to do what? Not to exert moment from the wall into the beam, or from the beam into the what? Wall. Means that the what is here, the M2 and M1 is what's here 0. Okay, that's fine. So with this now, we then now go what? Move out to what? Our plan view here. So with this now, you can see that we have successfully modeled for this structure and all that. The next thing now, go, let me just take this grid downward, back to story 0, all these grid lines. Okay, so right now we now move on to the what, into the modeling of this top here, because this top here has a different level here. If we check on the 3D view here, you can see that we have here is something like as if it's elevated. Okay, this area here, sorry, back to this part, sorry for that. Other image come up now, please. Don't my time. Yeah, this here now, you can see that here now is what there is. Here has a different level again, which is at the next floor. Okay, that's fine. If you also check out on the CAD file too, you also see that too on the CAD file. If we check the CAD file right now, what we have from the CAD file here, just hold on right now, you can see that from the CAD file. Can you see that? Let me just shift this to this place here, and then just shift this here. That's fine. Okay, that's okay. See that right now on this place, you can see that there is what elevation of what, basically what's the elevation else. The height of that place is what, let me just check that, from the slab here all the way down to this 2-3. Okay, but let me just start from this ceiling level here. From here all the way down here is what, let me see what happened there, 2.5. Yeah, 2.5. So 2.5 now becomes the height of this floor we are going to add up. Okay, 2.5. So with this now, back to our plan view here. So only this wall that has a staircase that will lead to access to this pool, and this lift that will also lead to access, that will have that what, that elevation, okay, of 2.5. So with this then do what, go and add what, additional story. So I'll then make my story 5 active first, because I want to add it from story 5. Okay, from story 5 that will be active. Then come now and then click on modeling, sorry, here, and then click on what, insert story here. Just click here and then insert story here. Click on this place now and then click here, sorry, this place, and then click here and click here. That's fine. And then insert what, story. Okay, here will now be story what, 6. Okay, 6. Okay, and then the height is what, 2,500. Okay, and I don't want to generate everything, all the beams. I don't want to leave that, because I want to only generate what, only this staircase area and the lift. So I'm not going to check this option here, and I'll just say what, okay. Okay, that's fine. Then say what, yes. Okay, so with this now, we will only have just the grid lines. We just do what, come up. Okay, only the grid lines will do what, come up. Okay, so with that, let me just hold on for that to insert. Then come here. Okay, it's done. And then you can see that we now have what, a story 6 that is what, empty. Can you see that? Okay, so let's now go and do what, go and add up that. Then come now to story 5. Okay, story 5. Okay, story 5 now. Then go to story 5 plan. Okay, now on this place now, we will just do what, transfer this other, the lifts and this staircase area to do what, to story 6. Okay, so I'll come now and then click on this here, hold my control key, click column. Okay, in fact everything around the lift. So I'll just come here, highlight this place like this now, highlight, correct, that's fine. Then go now, hold my control key and select the lifts. The lifts also go, all right, because the lift, we like have a slab at the top which will anchor the pulley of the lift. Okay, so I'll come now, right click now, and do what, generate members to other stories. Okay, and I'll say from story 5 to what, story 6. Okay, and I'll do what, come here and do what, say okay. So it will only carry those members which are done what, selected into the next story. Okay, which you will see just now. Now come and do what, close here. And if we go and check on our 3D view right now, you will see that we just have this now. Can you see that? Correct. So we just have this now. Can you see that? That's fine. So with this now, let me just check that right now. Okay, so I'll then come now and then begin to model this other side now. Back to my story 6 now. Now on this story 6 now, there is this place here has a slab. So I'll come now, click on my modeling here, then slab. All right, now for the slab now, let me just start with this other one here first. come to loading. Sorry, slab is what? 150. Okay, and then come here and put in my value here to be now let's see how the 3D view is first. Let's just come out first. Let's see that. Okay, so you can see that even the slab is going down by some values. Okay, you can see that, but basically you can just allow that to happen because this is just for covering. Okay, so let me just allow that without putting any value. Then come now and put what 1.2 because that's just a roof load. Then come again here for the here I'll put 1.5. okay, then now come here and then insert my slab there. Okay, that's fine. Now on this slab now, let's just done for that. Then for this other one now, which is the lift here now, for the lift I'll then come here and put my lift slab to about 200 minimum, and then come here and insert what the dead load, because forever that lift will be there. Okay, so you have to calculate what, calculate for your weight of your lift. Okay, and all that, and then use for your design. Okay, you have to calculate the maximum number of what occupants, okay, that we use the lift at once. Okay, so with that now, with that I'll then come now and then do here for the dead load here I'll just put 1.5 first. Okay, then put here life load, which is what 32, which is a lift load. Then come now and do what, insert it here. Okay, insert that there, that's fine. And then I'll then come now, click on this 3D view now to see what you have gotten so far. You can see what we have got so far now. Can you see that? Okay, that's fine. So then we'll now come to what, putting our wall load here. So I'll come now, click on any of the beam here. All right, right click here and then do here, click on this place here, edit load, and then come now and wall load here, and then come here and the height now is what, 2500 minus the beam of 450, which is above. So we have what, let me just check that on my let me just check that with you. Okay, calculator right now, calculator, 2500 minus 450, that's 2050, that's fine, sorry for that. So 2050, okay, and then 225, well, that's okay. And then come here now and then do what, insert, okay, and then come here and do what, okay it. So we now have what, our wall now will not be there. Can you see that, stopping directly below the what, beam. Okay, and then come now, right click on this, copy the load, I'll say copy the wall load, and then come now, click on this other one here. Okay, then click on this other one here and this last beam here. Okay, and then come now, right click here and paste load. Okay, so we now have what, our load here. Basically there's meant to be a door opening here, but I can just ignore it. They can do it aside. Okay, so I will ignore that opening. All right, and all that. Then we have now done this. So let's now go and look at again at the roof, because there are some walls that are meant to be at some places here. So they can look at the roof right now. Okay, now around the roof now, let me just click again on our 3D view here. Okay, we then have, let me just open up. Okay, so you can see that we have what, we have walls on this area here. Can you see that? And also on this area here. Okay, and okay, that's okay on this area and this area. Okay, that's fine. So right now we have our wall going like this, we have a wall here. Okay, so we're going to copy this wall now. All right, copy this, copy this wall. Okay, copy it, come here, click on this and paste. All right, paste the wall load, that's fine. Okay, then come again now, come to this side now. There's also a wall load here, click on this and then click on this here. Okay, and again come like this now and click on this here, then right click now and then paste load. Okay, that's fine. And then we'll have to modify this height later of this wall by minusing 450 from the height. Okay, so again Then let's just do again here. Okay, that's all we have. Let's now modify what we have here, okay, by minusing 450. So come down, click on this also, click on this also here, okay, and this other wall here, okay. Then right click now and delete wall load. This is the other one here, and modify that, knowing that the height of this wall was 1.5. If I click on this beam now, then right click here and do what? Insert wall load, edit wall load. So that will be 1.1, sorry, 1050, because minus 450. Okay, that will come now. That because we have that place to be what? Elevated before, 1050. Okay, and then come here, insert point 0 and 0, insert it, update, and then come here and say what? Okay. Now the reason why I did that is because that it can have the same level. Can you see that? It can have the same level. That's because don't forget that this place here has a step that caused this pool area to do what? Elevate by what? 450. So with that now we need to subtract it, because now here is higher than here. So we can have the same what? The same level. Okay, you can see that the same level of the parapet load. Okay, that's fine. So now copy this load now, which we have just done. Copy. So yes, copy, and then go and paste it now along this area here, this other one here. Come now and paste it here, right click here and do what? Paste. Okay, then just paste that. That's fine. So we now have this here. Can you see that? Okay, that's fine. So you can see that we are basically done our what with our modeling. Okay, now to make your this thing faster, as you can see that it is trying to scroll very slow, and that you can click to do what? Turn on your what? Turn on your performance mode. Okay, and all that, then it will show that. Okay, turn it on. Okay, then just hold on for that to turn on. It takes it takes some time to turn on, but less than let me say 30 seconds. Okay, and all that. So turn it on right now, and then say what? I just like to finish up. Correct. Now it's on. So with this now, you can choose to do what? Turn or rotate in here. Want to rotate, it will not lag again. It will stop the lagging. Okay, but just that you'll be seeing your you'll be seeing the lines on the beams and slab and anything, but it will make the thing lighter. Okay, so you can choose to now. So you can see that we are basically done with our model. Can you see that? We have done with everything that we needed to do on this model. Okay, now we are left with one. This beam here has a load, which is the load you are seeing here. This load you are seeing here. This load here you are seeing here. Let me just hold down that open. Come up now. This load you're seeing, there is yellow here. This yellow load here, which is like a sheet. Okay, we're going to apply it also on the beams. Okay, so come now and apply the load there. So here is what story 2. So back to story 2 now, plan view. Okay, story 2 plan view. Story 2. Okay, story 2 here. That's fine. Story 2 plan view. Okay, which is around this area here. Then go and turn on what? Go and turn on performance mode again. Okay, this turn it on only on the when you are on the 3D view. Okay, then come now model here, sorry, loading here, line load, then line load here. Okay, then here also 2.5. okay, sorry, 2.5, sorry for that, 2.5, okay, sorry, 2.5, that's fine. Then I'll have to remove this thing that's showing cantilever lines and all that. So come now, click on this here, go all the way down here and click on this. Okay, hold on for that. Again, from here again, go all the way down here and click on this. Okay, that's fine. And again, from here, go all the way down now and click on this here. Okay, again, and then from here, go all the way down here and click on this. That's fine. And again, go all the way down from here and click on this here. That's fine. That's okay. And again, from here, go all the way down now and then click on here. That's fine. Okay, so with this now, then we will now go to what? We will now go and do what? Go and remove these cantilever points here. All right, remove them, control key, and then just let them. Okay, that was done because we were having a column that was slender, that was going from gram down to the next level, skipping other stuff. Okay, so how to do what right now? Click on this here and click on this here, right click now, and do what? Remove on mark supported. Okay, that's fine. So you can see that don't have cantilever line again. They now come and do what? Hinge these other ones. Come now, right click here and do what? Hinge at both ends, because that's how it's meant to be. Okay, else it will transfer, else the beam will do what? Carry what moment into the column. Okay, then this other one here to support on I end. Okay, right click here and do what here? Come here, I end. Yes, that's fine. And again now, come here, click here, and also click on that one here. Then okay, no, here is not an end, so here should be as it is. Then come now and then click on that side here. Now we are done with that. If you now can check our 3D view right now, you can see what we have just done so far. Let me just show you right now. You can see what we have achieved. Can you see that? The load, all right? This is a line load, which have applied the load of that sheet, all right, on that place. So with this, you can now see how we have done this modeling. Okay, and we have done with this right now. Let me just take this grid downward, or even turn off the grid lines by going to display. All right, display here, and then come here and do what? Hide grids. Okay, you can see what we have done so far right now. We have perfectly modeled and loaded. You can see that only loading alone take us only 1 hour, although that's because I was explaining. That's why else it didn't take me less than 30 minutes to finish all the loading. Okay, even less than that too. So right now you can see how we have applied loading now to all this structure here. Can you see that? So with this now we have fully applied load on this structure. The next thing is now begin the structural analysis of this structure. Okay, which you are not going to use the normal way. We are going to do some changes, okay, and apply some things before we begin the structural analysis, because we are going to use finite element wall method to design for this swimming pool here, all right, and for the basement. Okay, that's fine. So with this now, let me first of all go out and then save. Okay, apply to save. Okay, that's fine. So once it's done saving now, we'll then move on to the settings before now perform the building analysis. Okay, so right now it's done saving right now. Let's now go and do what? Click on this place here that says analysis here. Okay, and then click on this building analysis there, and then come here and do what? Edit our material. Now on material right now, I told you that you are meant to choose your grade of this. I believe we did all this last time, but even at that, let me now show you again. So I click on this now based on the clients, all right, this client that owns this building can afford grade 25. Okay, so I want to use 25 for it because it has most water structure like swimming pool, and also have basement structure. Okay, so I want to use grade 25. Okay, for that. Okay, so with this now I will then come now and do say apply. Okay, and all that. But even if I can choose to use a different grade of concrete for different, like for walls now, which is concrete walls for pool and for basement and all that. Okay, but I want to just leave it to 25. Okay, another, because I know, because the client can afford it. Okay, so I'll come again right now for my grade of steel. I want to use grade 60. It's called grade 460 type 2, which is the rough grade. Okay, so I'll come and put grade 60. But if you know that your client cannot afford it, then choose grade 10, which is the lowest. Okay, but if you're in an advanced country like US, Jamaica, Western country, 500 is your own grade. All right, you can 500. That's your grade of your steel. Okay, so with this now I'll choose 460, and then come now and do edit my bars here, my bar sizes here. Okay, that's fine. So basically bar sizes change varies from different countries based on what you have in the market. But even if you have anything at the market, it is good to follow what the code says when you're doing your design of your structure. Okay, so right now on the design of structure, the code says that we are meant to use what this icon here is for column, minimum is for what, minimum diameter is what, 16, although the code actually says 12, right? But 12 based on experience used to fail a lot and all that, so it is best to use minimum to be what, 16. Okay, 16. So 16, 20 and 25 is my maximum. Now come here and look for 32, is too big. Same thing for beam, minimum is 16, 16, 20, 25, and take off this, is too big. Then for, okay, sorry, this is for wall, same thing. For beam now for beam now, I'll have to remove this, and also the same thing for a column, okay, and take off this. And for slab, okay, I want to use just the word 12 because I don't have a flat slab here, so I'll just choose 12, okay. And 12 is okay, sorry, 12, not 10, okay. We don't have rib slab here, so I'll just skip that. Then footing, which is for foundation, I can just choose 16, let me say 12, 16, and okay, and take off all this, it's too big. Then for links now, for links, I want to use them at 10 for my links, so I'll say 10 and what, 12, okay, and uncheck this, that's fine. Now I'll then come here, all that these ones here are okay for generic and all that, for wall lines and all that. So I'll come here and then do what here and say what, okay here, and then come now and say what, final okay here. So with this now, then come and do what, okay here again. So with this now, we have now done what, our materials, okay, and all that. The next thing we do right now is now do what, click on what, analysis here, okay. But before analysis, we need to do what, some settings, okay. Come here, model here, and come to share one model here, and say what, it will use not mid-spare model, but use what, finite element share model, okay. That's because we have what, we have a basement here and we have a swimming pool here. It is best to use this one so that the load can be easily what, transferred through the walls, okay. That's fine. So with this now, then come here and then come back to this place here, okay, and then click on the building analysis here, okay. So I'll click on this now and then wait for it now to display the next thing. Now, do you want to perform the building analysis and also the what, design at the same time? I'll say yes. So right now I'll check this, say design for beams and for columns, okay, and also with select bar if the 16 if the bar we choose as the what, as the minimum is not what, sufficient, let it choose what, the what for the what maximum, okay. So right now there is no steel here, so I'll not check anything like steel design, and then we'll now click on what, building analysis here, and then wait for it to now begin, okay. Now once it begins, we just wait for it to do what, finish, okay. That's fine. Okay, right now it's time to do what, run the building analysis and design. So just hold on for that to do what, finish up, okay. Okay, it's still running. Just hold on for that to finish up. It's still running the what, and the building analysis, okay. It's still running. So it's currently running the concrete, like the design now. As you can see that for the walls and for the column is almost done. Let's just hold on for that to complete. Okay, so we are currently right now on the concrete reinforcement design. So you can see how we have just done what, we have done the loading and how it took time to make sure we load everything. So when you are performing your loading for your structure, you must consider everything. You must put everything into what, consideration. Now let me see, I have seen your comment, Engineer Samuel. I can see your comment. I will just reply you later. Now you can see that we performed what, the loading, okay, and all that. How you can see how we carefully loaded everything and make sure we like do what, put all the loading into what, into consideration, okay. That's because we don't want to miss any of the loading, okay. That's fine. So you can see how I've done that. So you can now see that when you're doing your structures, basically you must have to do what, consider every loading, and you must have to load it what, well and accurately, okay. That's fine. So let's just hold on now for you to finish up the column what, design, because it's currently on column design now. Since it's a big structure and all that, and it has several members of structure and also several components of structures, so it will take some time to design. But let's just hold on for that to design. I just believe this live stream will not go up to 2 hours, because it's currently I believe 1 hour 24 minutes so far. So let's just hold on for that to complete right now, okay. So let's just do what that to do right now. Okay, so please, I would like you to share our video to your friends and colleagues, and also give this video a thumbs up, and also make our channel to go viral and all that. So thank you so much, and God bless you for everyone watching us live currently, and for everyone coming to also sharing our videos, and also recommending our channels to our friends, to your friends and all that. Most especially our friends from Zambia, you guys are doing great sharing. From Nigeria, you are doing so great. From Malawi, you're doing great. From Sudan, oh, those guys are wonderful. And then from Ghana, that's fine. From Cameroon, I love you guys. And then we also have other Western viewers from Jamaica, from Estonia, from India. Oh, you guys are much. Indians are much on our channel. Then also we also have from Switzerland. We also have some people from Germany and all that. You guys are doing great and that. Okay, yeah, I believe we basically started having viewers from Germany and all that when their code was added. Also Philippines, yeah, Philippines too, code was added recently on this version of Protastructure. So we are having viewers also from Philippines. You guys are doing great. We really love you guys. And then thank you and thank you and thank you and thank you. And if you have any support to give to Ekidel, there is a support link, link or donation down below. You can just put the price you want to donate, and then donate to Ekidel. We love you. And then let's just learn for that to finish up right now. Okay, so currently it's almost done with the column design. It's already 153 against 265. Okay, that's fine. So let's begin to have your comment, because soon the Q&A session will be open. So once you see the question and answer link added to the this live chat, you will do what you have to, or to the comment section, you have to do what you have to click on it, and then come to the other platform where we have to do what hear your question and answer. Okay, so currently now we are about adding the question and answer link. Okay, but we will have to do that once we're done with the building design and analysis. Okay, we then add the link to the question and answer. We will have to hear your question regarding this structure or anything you're having challenges in Protastructure. Okay, that's fine. So let's just wait for this to do complete. Okay, so currently now it's now entering into the beam design. Okay, so right now it is now entering into the beam design, which you are seeing right now. So let's hold on now for the beam design to also design. So basically it is done with the columns. Now we are now on the beam design. Okay, so hold on for that to finish up right now. So the beam design is still currently on, as you can see that. So just hold on for that to complete, as you can see. Yeah, like I said again, because of how big the structure is, it always takes time. Okay, as you can see that we are currently designing for a client here. Let me just open up that for you guys to see. We are currently designing a 30-story building for a client, as you can see that, a hotel building. Can you see that? 30-story, here is 30 and here is 21-story. You can see that. So you can see that this building right now, if you're planning to now design the structural analysis and design, it would take not less than, let me say, 1 hour or 2 hours, okay, to perform the design. So you can see, so when you're having bigger structures, okay, it takes time. Okay, so you can see how this building is. This is 30 story. Yeah, only the model, only to model alone itself took us almost 2 days to model. Okay, and to do the GA and all that. You can see that it's basically too big, right? Even if we have a powerful system, it's even lagging. Can you see that? So you can see how it's performing right now. It's lagging. So this is basically the model here. Okay, so you can see that is lagging. Okay, but if I begin to use this view here to view it, it will not lag. Okay, so if I need to click here right now, you can see that it's even lagging. So if I come now and then click at this point here and all that, so you can see that we are designing currently this other one too. So basically here on Ekidel, it's all about structural designs. Okay, but soon we are going to enter into other softwares like Start Pro, Protastructure, Start Pro, Advanced Steel, Greatech, and other advanced robot structures, and also other finite element analysis software like AMSYS, Abacus, Nastra. I'll show you other and also when to use that, okay? Not that. So let us go back right now to what we are doing currently, which is the other one here. Yes, here. Okay, so it's currently around, it's still working on the design, which is not yet done. Okay, that's fine. Just hold on for that to finish up right now. It's almost done with the column. Okay, yeah, the column is done. Now it's going for the beams. Okay, let's just hold on right now. The beam is almost done too, but let's just hold on for that to what finish up. Okay. Okay, so you can see that it is now done with the what, with the design. I can see that the drift between direction 1 and direction 2 is what, okay. So then go there and then do what, now say what, okay here. Now then hold on for it to do what, finish up. You can see that building analysis and design is what, successful and all that. Okay, analysis was completed at what, 14 minutes 23 seconds. Okay, that's way too long. Then come and do what, come here and then do what, close here. Okay, that's fine. Now on this, now once you have done your design and what analysis, next to do it is to do what, go and check out for the design status. Okay, be rest assured that some of the members will like fail. Okay, so right now we now go auto the review tab here, review tab, then go to the place that says what, visual interrogation here, and then click on this here, visual interrogation here. Okay, and then hold on for that to display. Okay, and then once that comes up now, okay, this now is here, then go to do what, scroll down and click on this place here, and then say what, okay. Once it's shown, you say what, okay here, okay it right now. Okay, that's so you can see that basically we have some of the this now have passed. Can you see that members have passed, while some of them are still failing? Can you see that some are failing and some have also passed? Okay, so with this now we just go and do what, attempt to the ones that failed. Like you can see that this column here is failing, and this beam here is failing, and some columns also, if you go down, you can see that some of the columns here are failing. Can you see that? So we will have to do this now and then rectify these other failures. Okay, so you have seen how we have modeled and performed what, the building analysis. Okay, so the next thing now we want to do what, go and begin to check. Okay, but we are already 1 hour 30 minutes live streaming on this design and all that, and basically I'm like tired. Okay, I'm tired, which I will want us to continue this live stream next time, by this time next week. Okay, the same time next week we will have to begin what, to begin with the design. Now begin to do what, check the structure and check each of the members that passed, and also check their what, check the reinforcement, and also correct these ones that failed, like the beams and columns that failed and all that. So right now you have now seen how we have designed, and also for all the pool walls passed perfectly. Okay, now you can see that a column here is failing. You can see that is failing. Here is a failure column. Okay, so you have to do a check for all the flaws and make sure that everything is passing. And even not just that they are showing green, even if they are showing green, we need to do what, check the software to do what, see the kind of reinforcement that was what given. Okay, and all that. So we want to do what, check the software too and all that. So be rest assured that by next week we're going to do what, check the software and see the kind of reinforcement, and also rectify these failures on the beams and some columns and all that, and make sure that everything is okay, that we have given approval on the reinforcement details and also on the section of the beams and all that, before we now go and do what, go and start performing what, detailing of this structure. Okay, that's fine. So you can ask now, I'll also attach the model of this Prota interface, the model template of this Prota, on this video description, so that you can also purchase that if you want that, and then look at for what I have done while you are trying your own. Okay, that's fine. So with this now, I'll be we are now come to the end of our live stream. Now we are moving into the Q&A section, which is what, question and answer. Okay, so you have to click on the link now on the live chat or on the comment section and move into what, question and answer section, where I'll have to hear your voice and then know your questions and also work on that. Okay, so right now we have come to the end of this structural design. All right, the next thing we do right now is to do what, moving toward checking of the designs and what members, and then perform what, foundation design, which will come up in other live stream. Okay, that will be coming up soon. Okay, that's fine. So then thank you so much and God bless you for everyone that will be here. Engineer Samuel, Engineer Calio, I can see that, Engineer Masuba, and so many of them, Engineer Fashil. I'll say you're welcome, and then thank you for being a part of this, and we love you. And then this is Easter currently. Happy Easter, okay? Happy Easter. And then to all the Christian brothers here, I'll say happy Easter celebration to all the Christian brothers, and to all my Muslim brothers too. I will also say happy end of the month and all that. Now we are going to next month being April is our what is our now why I am saying why I'm talking now, please click on the link so I can join the what Q&A session. So next month April is our 1 year anniversary, which is the 12th of April, 1 year anniversary, and we will be giving out what free mentorship on what design of structure. Okay, so we'll be giving out what free mentorship, so you can be a part of that, and then just a 1 week free mentorship, so you can be a part of that, and then what get more what knowledge on design of what structure. Okay, that's fine. So right now we are moving on now to the what and Q&A session right now. So we have ended the live stream for this design now, and then we are now going to what the Q&A what session. Okay, so let's now go and look at for that, right? I know that. Okay, so right now that we are on the Q&A session right now, for all those coming up right now, I would say that you should just click on the link and then join the Q&A session now, because we are now ending this live streaming now. Okay, then see you now, and see you all there on the Q&A session. Bye for now, and then thank you for being a part of this live stream. We love you, and then goodbye. Okay, then fine then.